Hey guys, so today we're going to be talking about how to find the pH of salts, and we're going to talk about how we can approach problems like this by doing a problem ourselves. So in this problem, we have 1 mole per liter of potassium chloride, and the question asks us to find the pH of the potassium chloride. So they give us the molarity, they give us what the compound is, what the salt is, and they are asking us to find the pH. So the number one first step that you have to do when it comes to finding the pH of salts is you have to dissociate the salt. Okay, so because we know that this salt, potassium chloride, will dissociate because it's a group 1 metal and it also has a halogen in there, because we know it's going to dissociate, we have to write out that reaction, write out that equation so we can better understand what our new reactions will be further on in the problem. So we have potassium chloride here, and potassium chloride will dissociate into a potassium ion, so K plus, and a chloride, a Cl minus ion. And the next step, so this is our first step, dissociating the salt. Okay, dissociating the salt. The second step that we should follow is we should take each of these ions and add water to it. Because we should make the assumption that if we have a salt and if we put it in a beaker, let me do it in a different color. We put it in a beaker filled with water, which has a pH, keep in mind, it has a pH of 7. Water has a pH of 7. So if we had a beaker here filled with water, if we put this salt in the water, we know that if we put the salt in the water, it will dissociate into potassium ions and chloride. That's the only way we can write this dissociation reaction. The only way we can do that is by adding this salt into water. So if we add the salt into our water, we'll get some chlorine ions in the beaker, and we'll get some potassium ions. So we'll get some K plus ions, and we'll get some some chlorine ions, excuse me. So with that in mind, we're going to have some free-flowing potassium and chlorines. And these free-flowing potassiums and chlorines will be reacting with the water around it. So the second step that we'll take is take each of the ions that we dissociated and add that to water. So our second step, I'll write it out, is taking K plus and adding it to the water that we have in our beaker. So K plus reacting with the water we have in the beaker, and some Cl minus reacting with the water we have in the beaker. And if we do this reaction correctly, we know that potassium ions will react with some negative charged ions, so we can take a hydroxide from this water, so we can produce some potassium hydroxide and some extra H plus ions from this water. Same thing over here, we can do some H plus with Cl minus, so some hydrochloric acid with some extra OH minus ions. So this will be our second step, taking the ions and adding it or reacting it with water. So after we did this and we got our products, we have to analyze our products. So our third step is going to be analyzing our products. So the two main products that we'll have in focus here is the potassium hydroxide and the hydrochloric acid. And if we take these two, the potassium hydroxide and the hydrochloric acid, we know that both of these will form a strong base and a strong acid. So they're going to be very, very strong. Now, what we should know already from our acid-base knowledge is that strong acids produce very weak conjugate bases, and strong bases produce very weak conjugate acids. So with this in mind, we know that these guys will not be affecting the pH of water that much because what they produce is very weak. And those weak conjugates don't have high affinity to H plus ions. So we should know, and I'll write this down, it's a very important concept, that strong bases and strong acids don't affect the pH of water. They don't affect the pH of water because they produce weak conjugates that have very low affinity to H plus ions. So if this is the case, if we have a solution with a strong base and a strong acid, we know that both of these products will not affect our pH. So we know that we have a solution of water. And we know that water, H2O, is a neutral solution. It has a pH of 7.00. So if we produce from this salt, from this potassium chloride, if we produce some strong base and some strong acid, we won't be affecting this pH. So our end pH of potassium chloride will still be 7.00. So the end thing that you should take away from this video is that if you have a salt and you dissociate it, and the ions that you dissociated it into add to water and produce strong acid and strong base, you will not affect the pH, so the pH of the water will stay the same. And we should know that the pH of water is neutral. It's 7.00, so our pH of a strong acid and strong base solution will be neutral as well. Our pH will be 7. Hopefully this video makes a lot of sense. If you have any questions, please put them in the comment sections below, and please subscribe. Thank you for watching the video, and I hope you tune in for more.